Thanks again for joining us today for What's New in Solid Edge ST10 webinar series. We will be highlighting what's new in Solid Edge ST10 and show you how the latest version can help you design faster without the constraints of traditional 3D modeling. My name is Elise Woods and I'm a market specialist here at Swiss Technologies, and I will be your host for today. Just a little background on Swoosh. We're partnered with the best when it comes to providing software solutions, technical support, and process-based training. We're an award-winning leading provider and partner of Siemens PLM and have also teamed with the leaders in the industry, including SMAP 3D, Markforged, CamWorks, KeyShot, and Mentor Graphics. We're committed to delivering professional and educational services that optimize your everyday design and manufacturing processes. Presenting today is application engineer Dylan Malik. For over 2 decades, Dylan has seen the growth and changes of CAD design and understands how the latest technology has really benefited many companies' processes. With his hands-on experience in sheet metal fabrication, structural design, surfacing, rendering, animation, and 2D drafting to 3D modeling. He is a certified Solid Edge professional and is a sought-after Swoosh training instructor with a great working knowledge of best practices that can help your team better deliver products painlessly. Solid Edge ST10 combines new capabilities to accelerate your workflow and pushing your productivity. Today, Dylan will be talking about built-in synchronous modeling and sheet metal. In synchronous modeling, it is important that a sketch properly define a shape at the time the sketch is used to create new features. Whether or not the shape is fully constrained does not determine the appropriateness of the shape. Such constraints defined on a sketch are consumed when the shape is used. They no longer constrain the resulting features. Dylan will show you the changes that we've brought into the ST10. Also, during the presentation, if you have any questions, please feel free to put them in your questions box. They will be anonymous, and Dylan will try to get to all of your questions at the end of the presentation. So I am going to go ahead and switch this over to Dylan and let him take the presentation away.
All right, thank you, Elise. All right, thanks, Elise. Let's kick off here. I just got a couple slides to describe what I'm going to be showing you today. First one, there's not a lot of new stuff in sheet metals. Just one in particular is cut across bins. So what you see on the picture on the left is kind of the behavior that you would see in previous to ST10, where a cut across a bin in Synchronous would deform. It wouldn't stay the actual shape that you created it when you moved and or drug a face as shown in the picture. Ordered still works the exact same way, which is how you'll actually see Synchronous work. So I'll show you how that is done. All right, the next thing is in parts. It was a big one. This is something we also see in NX. It's a generative design. And just simple enough to give you an explanation here is a Wikipedia description. It's generative design is a form finding process. So that's basically what the generative design does. It's taking an algorithm and going through a whole bunch of permutations that you would take a long time to generate and do analysis on. So it's just a really fast kind of shortcut to get to maybe it may not be your final state, but it will get you in the ballpark of where you want to be. All right, and the last one is the ability now to bring in STL files and modify them. We could always bring in STL files, but they were just purely visible. You couldn't do any interactions with them. But now we have the ability to do some addition and subtraction of the geometry. So I will cover that as well. So let me get over into Solid Edge. We have a file here to look at. So this is the one I showed in the description. So here we have our bins, our cut across a bin. So if I grab the face, and again, this is a synchronous model, so I'm just using the steering wheel to grab a face and kind of pull it. You'll see immediately that the cut across bins now do kind of exactly what they are supposed to do. So if I just pop that out to 7, that's good. So and another thing to notice, if I actually do grab one of the radiuses, you notice we do have our design intent that pops up. And we do have one for aligned holes. There you go, right here. So as I drag this across here, this should maintain all these lined up. And you can see what happens here. It's moving and behaving as intended. All right, so to create one, I'll just go ahead and show you what the process is. It's a simple step. Just draw your profile. I'm just going to tie to that base right there. Give it the size you would like. 12, and position it from a location that you can change. Center to the edge here. That works right there. All right, so to get that to, I actually should have drawn this face, but this will work regardless. Come over here now and do a cut. So if I say cut, notice we have two regions across here. So I'm going to tell that to grab both regions. And here's the button that you would actually use to wrap a sketch cut across the profile. So when I do that, you notice it unbends the profile temporarily. Puts my feature on there. All my dimensions still maintain. And once I accept it, it will populate that and go ahead and put it on there. You notice the dimensions stayed attached to the geometry, so I can now move this if I wish and or change the size of it. So that is now new to Solid Edge ST10 sheet metal. Okay. Switch out of here. All right, so the next one I'm going to cover is a generative design. So I'm going to start with a new template. I'm going to create some geometry here to work with. This is the size I need. Oops. What I'm doing here is creating a general shape. I'm going to need a pillow block bearing. So I'm going to need the actual casting to hold the bearing. So what I'm going to do is, let's say I have a 2-inch bearing, so I'm going to make a 2.5-inch hole for the bearing to sit. So there we have it. That's about as far as I need to go. So I'm going to switch over to a tab where we have generative design now. Of course, we need to give it some parameters. I gave it size, but now we need to give it some material. All right, let's go ahead and, since it's going to be a cast material, let's go ahead and just make it cast iron. Create a new study. And again, what's nice about this is you can create as many studies as you wish and kind of just look between them by changing certain parameters. And again, that's a lot faster than you could ever do just trying to create some complex shapes. And you'll see what I'm talking about here in a minute. Right, so let's just go through the list here. So the design space, that's going to tell it which geometry to work with. This is a part environment, and of course we can also create multi-bodies in our part. So I could create 4 or 5 different parts in here, but you can only generative design on one at a time. So let's just go ahead and say that's the part we're going to work with. All right, so preserving regions. I know this is going to mount to a base, so I want my base to be something flat. So I'm going to go ahead and say preserve that, and of course the bore is something we're going to push a bearing into, so let's go ahead and preserve that as well. All right, so I have my 2 regions to preserve. Some manufacturing settings. I'm going to say let's remove some internal voids, and you can see my coordinate system here. I'm going to say no overhangs in the Y direction. So in this axis, you won't have any protrusions popping up. All right, so that's it for there. All right, so we have some load calculations. Force, pressure, and torque. Since this is bearing, there's not going to be any torque because it's going to be spinning in there, but there will be a weight of a shaft and possibly a drive, a gearbox, something hanging off of it. So I'm going to use the steering wheel tool to find my the direction of the force, and let's just make it 300 foot-pounds. So we have a 300 foot or 300 pound drive hanging off, and let's tell it where it's going to be located at, and it's going to be fixed at this base right here. All right. So if you look over here in my Pathfinder, we got all our different parameters. We can obviously go back and change them anytime we want, but we're good there. So let's go ahead and say let's create our generative design. All right. So here, notice we have this little slider bar. For this demonstration, I'm going to keep it fairly low because you can see it only takes a minute. But if I bump that up to really high, it could literally take several hours to go through and process. But the higher the resolution, or the higher the tolerance, the better the resolution and the smoother the finish you're going to get. But for this one, let's go ahead and keep it around 6. All right. Next slider bar. How much mass we want to take off of this? So this is a percentile. So right now, it's the default's 50%. So let's stick with that. Let's just say cut half the weight out of this block and generate. So as it's doing this, it takes, again, a minute or two to generate through this. So what it's going to actually create is a body for me, and that body is going to be a mesh type body. So that kind of leads me into the ability now to interact with STLs, because I can add some other geometry to it. So maybe we're going to take this once it's done generating, and hey, it looks good. Let's make a rough casting of it or something. So we can make a mold. So I'll actually do that as soon as it's done finishing its mesh. It's pretty close to being done. Very good. All right, so it's just telling me this contains facets that can be greatly increased. So you can see what we have here, pulling 50% of the geometry off of there. It actually kind of pushes the geometry in at the bottom, and it's kind of warped at the top. That's easily, if I wanted to come and create another study, or if I can come back and say, there's a design body again, let's go ahead and generate this time, but let's take, instead of 50%, let's take this down to about 35%. Let's see what we get. All right, so this is a third-party developed tool by Frustum that's added into the Solid Edge interface. Again, just like reverse engineering, the data management, simulation, these are all built-in tools into Solid Edge. So you're working with the same type of environment. Oh, there we go. So that looks a lot better. You notice we don't have that indentation at the bottom, and it's a lot smoother at the top. You got the sides. I told it, again, not to protrude outside my y-axis. So that looks like a fairly good part to cast with. All right, so again, this is a mesh body. So if I turn the shading off, you can see we got a tessellated surface body. And of course, the solid block is underneath it. So if we ever need to go back, we do have the original design body. So if you need to make changes and maybe make this a little bit larger, run another generative study on it, just to compare the two. So we can do that. But I wanted to show you is the ability, again, we can interact with this. So I'm going to come over here, just like we do in any other type. I told you we can create multi-bodies. I'm just going to call this first one tool. Second one, we'll call this the mold A. Come over and just, again, create some quick geometry. One direction. Yeah. So the interaction, I can come now and go ahead and say, I want to join these together, but I want, in this scenario, go ahead and subtract from that body. Forgot to do something here. When I did that, I created basically a solid body. But again, you notice this little symbol outside of my tool has this little thing that says convert to mesh body. That's what I needed for this mesh body to interact with this solid body. I need to turn the mold into mesh as well. All right, so once I do that, tell it how fine a resolution, doesn't change anything. It works the exact same way, but now I come over here when I subtract, we will not get that error. So I'm going to say I want to subtract that body, and there we have it. So now we have a mold cavity to work with. And again, if we can add other features, maybe we need to add a port or something, or some screws or ejector pins. So this is still an editable body. We need to come and add some features too. What I forgot to show you is actually the last step. Turn that off, turn the tool back on, activate that body. We can show the stress. Right, so so this is actually showing the stress riser points. It's not like what you would get in simulation where you can probe and get accurate feedback. Again, this is kind of a getting close kind of tool. So that is what we refer to as generative design. All right. So let me get out of here. So open up STL. All right, again, so we have an STL file. Let me show you again the mesh body of this. So you can see all the little tessellated triangular surfaces that makes up the solid. So again, anything we have to work with, we have to make sure we make it also a mesh body. All right, so let's say we get an STL and we don't have the actual design model, and we have an engineering change. Let's say we need to get rid of this pocket. So the lightning hole does not need to be there anymore. So let's switch over to reverse engineering. All right, so I'm going to have some few tabs here. You know, some of these are similar. These at the end are from here to here are the exact same ones you see on your surfacing. So I'll show you what those are. They're the exact same tools you see, just in a different environment, just to do a couple different things. So let's go ahead and get rid of some mesh. All right, so we have a couple options, mesh and mesh facets. Maybe for some reason you get to open an STL and it's got multiple bodies in there. Mesh would allow you to pick entire entities to get rid of instead of just using what I'm going to do, which is mesh facets. So let me go ahead. Oops. So I'm going to say mesh facets. Don't want a box. I want to use with the little brush selection. So I'm just going to come and sweep that brush and grab all these little triangles on the inside. Shoot them all. Oh, dang it. I do that all the time. I needed to deselect some of those. Hang on one sec. All right. What happens sometimes is if you're not careful, which I wasn't, I inadvertently, let's rotate this over and make sure I didn't, sometimes grab some surfaces from the opposite side by accident. Looks like we're good there, so now I can go ahead and get rid of that. So now we have a nice clean hole on both sides to work with, and let's quickly do this one out here as well. So the bottom one hole is going to be missing now, and I can just paint the small one on the inside. And you can see this one has very tight mesh, so that it's a high polygon count STL that we're working with. And sometimes your STLs are low res, so you don't get as much mesh. But that looks good right there. All right, so we got a part that has 3 holes in it. The next tool I'm going to show you is actually something that's very useful. It's not just necessarily for manipulating, but if you want to print your STL, you typically would need a watertight geometry to work with. So what we're going to do here is fill these in, and this could be done on an STL that you necessarily didn't modify. It just may have a missing surface that you can let this tool work with. All right, so you notice what happens here. Once I accept that, it actually turns that solid body into surface bodies. So this is still an STL, but it's just a thin wall surface, so definitely not something you could print. So we have a next command called fill holes. So I'm going to go through, and it goes through and interrogates the entire geometry and looks for any open faces. We have a list of them here. I'm just going to do the 2 on the top first. So that's hole 2. Hole 3 is that one. So on the hole 1, I'm going to go ahead and take that out of the selection. So I'm just going to let it fill these holes. And we have some obvious selections here, tangent, curvature. That'll just be tangent. Let's go ahead and accept it. And there we go. Looks good. All right, so we have that patched. Let's go ahead and do this last one. Fill hole again. And just, you know, we'll only have 1 in here now. So that's the one we're working with. Say OK. And the reason I do this separate is so I can actually take it out. Because the first time I did it, I noticed tangent makes this kind of hump in the middle. So we do have other options, named linear. Let's see what it looks like. And of course, it's a little less, but if I go to the side view, you can still see that it still has a kind of a protrusion sticking out. So let's go ahead and add that. And I'm going to do another step, which is delete a little bit more mesh. All right, so I'm going to simplify this face. So by because what's happening is these holes, excuse me, the rounds in the corner going up this curved face is really confusing it on how to fill this area in. So if I just get rid of that, now we have a little easier face to patch. I'm going to come over here and say fill holes again. So computer's taking a second to think. There we go. All right, let's go ahead and just take the tangent option, and you can see it's actually looks worse than it did previously. But if I switch to linear, which is what I wanted, we get a nice smooth surface patch to work with. So there's a side view. We don't have the hump anymore. So let's go ahead and accept that. And there we have this geometry. You notice what happens over here. It turned in from a surface feature back into a solid feature, but it's still a surface. So I'm going to come over here and say toggle design construction, and it turns it back into a solid model again. Of course, we still have those faces here. And if I don't really, you don't want to see that, you can kind of delete that. Let's go ahead now, and as I mentioned, this is some generative design that we can add some things to this. All right, so you know, obviously I could fill this hole in, then patch it up, but we can also do some things. We can extract some surfaces. Again, this is a tessellated surface body. So let's go in and say we want to fill one of these holes in. All right, so we have these tools right here, automatic and manual. Automatic just looks at the entire body, but sometimes you don't want to make a surface out of the entire body. Sometimes you just want certain areas. So for example, I'm going to take this and let's just, again, paint the inside of this cylindrical body. The cylindrical surface, I should say. And let's make it color. Now I'm going to use this fit command. I'm going to tell it to, I can turn that into different types of options. And I'm going to tell it just to go ahead and offset a little bit and just turn that into a cylindrical feature. All right, there we have it. So now that is basically a surface body that is driven by the geometry. So for example, I can come over here and patch that off. And I can also bound that face and bound that off. Then I could kind of stitch these together. Say yellow stitch. There you go. So I created that other body. Again, we can convert to mesh body. Or if I wanted to actually manipulate it first, let me go ahead and activate it. So maybe you want to go ahead and move a face in or out, or just to the edge, or what have you. Let's just go ahead and pull it out here. Say we need a pin in here instead of a hole. So now I'll come over here and union that and that. Did I? Oh, I did. There we go. So I basically made that into, now that's its own. So if I mesh it, you can see that it is now part of the geometry meshed in there as a single feature. All right. And if I want to, again, let's say the engineering change was to get rid of the pocket, but we need a boss at the bottom. So I do, since I left that here, I do have a location now to position that with. So I can I want to actually, I'm sorry, let's actually add a body. There you go. Because again, I want to add some other features to this. If I create it as a mesh body, then I can only create it, and that's pretty much it. So I just want to grab this entire sketch profile. There we go. All right, so if I created this as a mesh body, I would not be able to come back after the fact and either do a chamfer on it or actually create a hole on the feature. So this part basically, I'm going to put a hole right here. something that they added in ST10 to the whole table is the hole size. So I'm in ANSI right now, and if I come over and say, let's, I need a 2-inch hole. Oops, switch too quick. So if you switch back and forth from template, so metric to ANSI or ANSI to metric or any other style, it automatically convert the text so you don't have to go do the calculations, figure it out, and or type it in. So it gives you the next closest size that would match. So let's just pop that on there. There we go. So again, that is the design body. So if I wanted to put some dimensions on it, maybe I need to position it to the end. So that is drivable. All right. So, but once I attach it, remember, once you have to do that, you have to convert it to a mesh body, and then kind of just union those together. And you notice dimension becomes not usable at that time again because this turns this back into a tessellated surface geometry. So now that feature that I created as a solid is now again joined with the mesh body of the STL. So at this point, I could go ahead and this was ready to go. I can file, say, save as, and save as STL, and pop that out, and either 3D print it, which was the intention is this one, and obviously the other generative design is more for casting. So working with mesh bodies, and again, this is the first release, so hopefully there's some new technologies coming out in the future. All right, so that is what I have new for sheet metal and a couple part environments at least. Is there any questions?
Yes, we do actually have a few questions. One is, can the STL files be brought into sheet metal to use sheet functions, maybe flattening the shapes?
No, not at this point. That actually would be a really good enhancement. And again, they're open for suggestions, so didn't really even think about being able to do that. But you could bring it in as an STL. You would not be able to flatten it, but you could design around it. Basically, use it as a surface body, then draw your sketches and create another sheet metal part around it. Then you could flatten that for sure. That would be a kind of a reverse engineering way to do that, designing around it as opposed to turning it into designable for sheet metal. So that's good.
Okay, thank you. Another question. If you have multiple STL files, can you bring them together in a single file and merge them together?
Yes, absolutely. Yeah, so once a part is saved as an STL, I don't know if I have any other, but you can insert a part copy. So I can go out there to another part file and insert an old file here. So technically, yeah, you can insert multiple bodies inside of here and place them and use, again, you could use the Synchronous tools to position them. I'll grab that, and so whatever I did, you notice this one is a lot larger than this one. But I've got it. Let's get a body. I don't know what the other one was scaled, but we do have a scale body command now that we can use. Let's just say 50. I don't have no clue. Well, that's way too big. So it's probably half that scale. So I probably doubled it when I brought it in. So yeah, we can insert part copies. We can mesh bodies. Again, if I wanted to convert that to a mesh body, then union it with the other one, and or scale geometry anytime I want. So that's all new to ST10. So yeah, I actually did a webinar on it not too long ago. Check out our YouTube page and some STL manipulations. So that gives a good example.
All right, great. We also have another one. What do you do with the files after you run the generative design tool? Is there a recommended 3D printer that's used for this?
We don't have one recommended. I mean, we can recommend some. We do. We sell Mark IV printers, which are carbon fiber based printers, which work really well. Let me get rid of that other STL. I don't mess with this much because I typically seg as STL, but there is a 3D print. This came out in ST9, but it allows you to drop this into a built-in this will actually export to something from Microsoft 3D print. But if you want to go on and go into an online order, this will actually take you out to some website. So maybe you're looking for a part that's maybe plastic, or sometimes it's metal. So you come through here, and as soon as it's building, so here it is in STL format. So you go out and sort by price or popularity. It's still loading. And it's probably because that part is way too big. Again, I scaled it, so it's way too big than it's supposed to be. But what you would do is you can just tell it what type of material you want, plastic, and it gives you vendors that will make a plastic part, and they typically give you a price, and you can actually just order right through the Solid Edge interface with these folks. So if you don't have your own 3D printer, there's a myriad of them out there you can select from. If you, again, want to talk to us, we have some options for you as well.
Okay, great. We have another question. Is there any difference in starting with sheet metal environment .psm file and then switching to a sheet metal and a part file?
No, because anytime, even if you start as a part file, it's really easy to, it's just one button to transform to sheet metal. So if it was a converted file, you opened it up, it would have a single part feature, but you just go to transform to sheet metal, and it switches to sheet metal features, and then you can switch back and forth. So you can add part features and or sheet metal features. There are certain part features that won't flatten, but we do have what they call blank body, which will flatten pretty much anything I've ever seen. So you can get a flat pattern, pretty much anything, whether it's designed in part or sheet metal. But if it's sheet metal, it's better to stick with the sheet metal tools in there and convert it to sheet metal to work with. That's a little more accurate.
Okay, again, thank you so much for joining us today. And if we were unable to get to your questions, please know that we'll get them sent to Dylan, and he'll reach out to you via phone or email to make sure that you have answer to your question. We also have another session coming up. It's on Thursday, November 15th at 2 p.m. Central Time, and this will be on assembling and drafting. And if you haven't registered yet, you can go to the link on your screen to sign up. And be sure to look out for the replay email that I will be sending to you. It will hit your inbox in the next few days.